Good morning, students. Today again we are going to start with the chapter Metals and Non-Metals, discussing the topic chemical properties of metals and non-metals. Last time we did the reactions of metal with oxygen. So talking about the reactivity of different metals with oxygen is different. So metal like potassium and sodium, I told you they react vigorously with oxygen and catch fire if kept in open. Hence, they are stored in kerosene to prevent burning. If magnesium is heated, it burns with a bright flame. That is, the white dazzling flame color is there. If iron is heated, it glows brightly. If copper is heated, it does not burn but forms a black coating of copper oxide. Silver and gold does not react with oxygen even at high temperature. Some metals like magnesium, aluminium, zinc and lead form an oxide layer over it which prevent further oxidation. So they are called as self-protecting metals, as I told you in anodizing in aluminium. Now talking about the reaction of metals with water. So a number of metals react with water to form hydroxide or an oxide along with evolution of hydrogen gas. However, reactivity of different metal is different. Some metal react with water at room temperature, some of them react on heating, some other react with steam only, whereas some do not react even with steam. So, discussing the few examples, as we know, metal react with water to form metal oxide or metal hydroxide and hydrogen gas is being evaluated. First of all, sodium and potassium. They react even with cold water very violently and the reaction is highly exothermic. Hence, hydrogen gas evolved catches the fire in this case. So, the reaction as you can see, sodium reacts with water. There is formation of sodium hydroxide and hydrogen gas. Similarly, potassium, it reacts with water. There is formation of potassium hydroxide and evolution of hydrogen gas. Now reaction with calcium. Talking about calcium, calcium also reacts with water at room temperature forming calcium hydroxide. This is the formula of calcium hydroxide, CaOH twice. But the reaction is less violent and the heat evolved is not sufficient for hydrogen to catch fire. So here in this case, the reaction is exothermic, but the heat is not as much as so that hydrogen it catches the fire. Further, he is saying the bubbles of hydrogen gas in this case stick to the surface of calcium and hence it starts floating on the surface of water. Next is magnesium. Magnesium reaction is not given, but I am telling you. Magnesium does not react with cold water. It reacts only with hot water forming magnesium hydroxide and hydrogen gas. And the reaction will be Mg plus H2O. There is formation of MgOH twice plus hydrogen gas. And it also starts floating on the surface of water due to bubbles of hydrogen gas sticking on its surface. Note that with steam, magnesium form magnesium oxide and hydrogen. Okay, with steam I am telling you. So when magnesium Mg reacts with H2O, there is formation of MgO only, not MgOH twice. There is formation of MgO, magnesium oxide plus hydrogen gas. Now experimentally to study the reaction of metal with water, take water cold or at room temperature or hot in a beaker so that it is half filled. Put small pieces of metal into it and cover the beaker immediately with wire gauze or a clock glass so that nothing splashes out of the beaker. Next is with aluminium, zinc and iron. Aluminium, if we talk about aluminium, he is saying they neither react with cold water nor with the hot water. They react only with the steam to form metal oxide and hydrogen. So in this case, only metal oxide is formed, not metal hydroxide. Like we can see in aluminium, it reacts with water and there is formation of Al2O3 plus hydrogen gas. Similarly, iron. Iron, it reacts with water and there is formation of Fe2O3 or there may be formation of Fe3O4. Okay, plus evolution of hydrogen gas. So experimentally the action of steam on any metal can be studied by setting up the apparatus. Like we'll take a test tube, in that we will at the base. We will in glass wool, we will be glass wool, glass wool is taken and it is soaked in water and kept at the bottom of the test tube, and the metal somewhat inside in between the test tube, and then start heating the glass wool. So first the metal sample placed in the middle of the hard glass tube or boiling tube, and the glass wool soaked in water placed near the close and is heated to produce steam, and which passes over the heated metal. The hydrogen gas produced is collected by downward displacement of water. Okay, so this is how the activity is being done. You can see in your NCERT book the diagram is given. Talking about lead, copper, silver and gold. These metals, they do not react even with steam. So what will be the order of reactivity? First will be potassium. It is most reactive. Then sodium. Then calcium. Then magnesium. Then aluminium. Then zinc. Then iron. Then lead. Then copper. Then silver and then gold. Okay. So the reactivity of different metals is different with water. Sodium and potassium, they react violently with cold water to form sodium hydroxide and hydrogen, it catches fire. Calcium react less violently with water to form calcium hydroxide and water and does not catch fire. While calcium, it starts floating on the surface of water. Magnesium reacts only with hot water to form magnesium hydroxide and hydrogen. And in this case also, magnesium, it starts floating on the surface of water. Why? Because due to the bubbles of hydrogen gas, its surface, they will stick and they will come on the surface. Metals like aluminium, iron and zinc, they react only with the steam to form metal oxide and hydrogen. And metal like lead, copper, silver and gold, they do not react with water. So this is about the reaction of metals with water. Now next is reaction of metal with the acid, basically the dilute acid. So on the basis of their reactivity with dilute acid, metals have been classified as more reactive metal, less reactive metal. Now what are more reactive metals? These are those which react with dilute hydrochloric acid or dilute sulfuric acid and displace hydrogen of the acid, forming salt. With hydrochloric acid, the salt formed are called metal chlorides, whereas with sulfuric acid, the salts formed are called sulfates. These metals include potassium, sodium, calcium, magnesium, aluminium, zinc, iron and lead. And less reactive metals are those which do not react with above acids to produce hydrogen gas, and these include copper, mercury and silver. Even the more reactive metals do not react with same vigor. Some react vigorously, some react slowly, whereas some other react only on heating. So taking the few examples, we will explain. So he's saying metal react with dilute acid to form salt and hydrogen gas. This is the basic reaction. Okay. So again, we can start with the first of all sodium and potassium. Like potassium, when it reacts with HCl, here instead of magnesium, if we take potassium, it reacts with HCl, then there is formation of KCl, potassium chloride, KCl plus hydrogen gas. Similarly, sodium, Na plus HCl, there will be formation of NaCl plus hydrogen gas. Okay. So they react violently with dilute hydrochloric acid, which sodium and potassium, and forming their chlorides along with evolution of hydrogen gas. Now talking about calcium. Calcium also react vigorously, though less than sodium and potassium. What will be the reaction? Same here, you can write it Ca plus, here will be 2HCl, then there is formation of CaCl2 plus hydrogen gas. Okay. Similar with magnesium. Magnesium, it's given Mg plus 2HCl give rise to MgCl2 plus hydrogen gas. Magnesium react quite rapidly, but the reaction is less vigorous than the calcium. Okay. Now next is the aluminium. Talking about aluminium, aluminium react with dilute hydrochloric acid slowly in the beginning because the surface of aluminium is already covered with a protective layer of aluminium oxide. However, after this layer gets dissolved in acid, the reaction becomes fast as now attack take place on fresh aluminium surface. So what will be the reaction? The reaction is Al plus HCl. There is formation of aluminium chloride plus hydrogen gas. Zinc. Zinc reacts slowly with dilute hydrochloric acid to form zinc chloride and giving out hydrogen gas. What will be the reaction? Zn plus HCl, there is formation of ZnCl2 plus hydrogen gas. Similarly, iron reacts very slowly with dilute hydrochloric acid giving iron 2 chloride and hydrogen gas. So what will be the reaction? Fe plus HCl, here arrow will come, FeCl2 plus hydrogen gas. So we can say that copper, mercury and silver, they do not react with dilute hydrochloric acid or sulfuric acid as already mentioned. Thus the order of reactivity of metals towards dilute hydrochloric acid or sulfuric acid, that is also dilute, is in the order number 1, that will be potassium, then sodium, then calcium, then magnesium, then aluminium, then zinc, iron, copper, mercury and silver. So how we can see these reaction? What we will do? We can say that we will take around 5 test tube, okay, with equal amount of all the metal like magnesium, aluminium, zinc, iron and copper. Cut them into small pieces and put them in separate test tube, each containing 10 ml of dilute HCl. So we will take 5 test tube. We'll put all the metals like we are checking the reactivity of magnesium, aluminium, zinc, iron, copper, and we will put the pieces of metal in each test tube. That is a 5 test tube, and then we will put the we will fill half of the test tube with dilute hydrochloric acid in each test tube. Now observe the rate of evolution of hydrogen gas in the form of bubble. Okay, the rate of evolution of bubbles and hence the